just by show of hands, how many of you know what a sabka is? A sabka. Ever heard of a sabka? Well, sabkas are really nasty things. They're typically found along the Gulf Coast in Saudi Arabia. And what happens is they get some groundwater coming up underneath the desert, and then they get a hard, crusty top on them. So if you're driving, let's say, a tank on your way to Kuwait or Iraq, you tend to fall into them and get stuck because they're kind of like gumbo. And it just turns out that if you know how to do a tassel cap on a Landsat image, sabkas stand right out in the middle of the desert. And I found that out the hard way as an Army topographic officer during Desert Storm, the first Desert Storm, just to age myself, when I had to load all my Landsat data by 9-track tape, 2 bands per tape. So we just fast forward another decade. My second seminal moment with Landsat was at Tora Bora. And I was working in a little windowless room in what was called the Mazant cell, because multispectral is special measurements and instruments. That didn't even rank with IMIT. It was special measurements. But you're looking at Landsat, we were able to determine the land cover right around Tora Bora. And we actually predicted, with that data set and some others that we had available to us, the 3 most probable routes that Al-Qaeda would use to escape Tora Bora. And sure enough, after subsequent analysis, it turned out that is exactly one of the routes we picked was exactly the way that bin Laden left Tora Bora. And we didn't hit him because our coalition forces wouldn't allow us to plant scatterable landmines back behind the Tora Bora facility. We could have cut off his escape routes, but our European friends said that if we used our scatterable mine system to stop those avenues of escape, that they would pull out of the coalition. So we didn't. That's a true story. So there's 2 seminal moments with Landsat. In those days, I was loading Landsat with DVD. And now the 3rd seminal moment is now, because when I can go into the Amazon cloud and I can have access to every Landsat image that's being taken now and into the future, plus we're kind of backpedaling and actually loading historical stuff, it is going to be a game changer. And it's a very exciting one that I'm more than happy to be a part of. And Esri kind of has this philosophy when it comes towards imagery. And we put this together, and it's very simple. It's see the world, find the patterns, share with others. And that sounds very generic, but if we kind of, spin it down a little bit, what if we were to say, see the forest, find the pine bark beetles, share with the forest harvester? Or see the agricultural fields, estimate the crop yields, share with the commodity brokers. Those are the types of things we want to drive through with our chain of processing when it comes to imagery. And that's how we've set up our imagery solution inside of Esri. And of course, it's all designed to take advantage of the cloud. I didn't label it Amazon here, but that is our preferred solution. It's an excellent capability. And around it spins the ArcGIS platform. Underneath, you have your content being provided by servers producing services. On the other side, you have your professional GIS image processing people. They might be using desktop, or they might be using a solution in the cloud, or they just might be publishing data, taking advantage of that content, doing analytics, and coming up with answers that in turn can be shared with any device, anywhere. Now, if you look at the whole see, find, share, you see exactly how that plugs into the model. Content management's your C. Finding the pattern is your analytics and your analysis, and sharing is the building of apps. So the ArcGIS platform fully supports image processing, which is what we like to see. So let's take a look at this front end, which is this whole notion of C, which is actually, putting the imagery into the database and being able to access it very quickly using a number of content management tools. And that's exactly what we've done with Amazon, and we've done it very efficiently using a data model that we call the Mosaic data set. And we take advantage of the tiling format that the Landsat data is put in, and we can then use that Mosaic data set to go in and do all types of search and discoveries for the data. A very simple application is a catalog. Esri's made 4 or 5 catalogs for some of the biggest agencies around, including Census and others, that allow them to go in and search and discover data, okay? But more importantly, we can do this on the fly. We can just type in an address or a town name or whatever, and it will automatically take advantage of the entire content management stack and find exactly the imagery that we want to look at. So content management is very important, but we added a twist to this. In the old days, the way I used to do it as an Army captain is I had all my data sources out there, put someplace securely, I knew where they were, and I probably knew them by file name. And as the expert, I would go in, find my data, and I would produce content based on a request from an end user. But now we switch over to a content on demand model, and this is what Amazon allows us to do. Not only can we manage our content, but we can push our analytics into the cloud. And we can actually do dynamic image processing on this data on the fly and serve it out to the users. And what's important here is you don't need this expert in the middle. The expert sets the whole processing chain up, but then once it's up, the user can just go in, draw their bounding box wherever they're interested on their map, and the product is dynamically made on the fly and sent out to them. And that's what we're trying to support. It's very exciting. And so just in conjunction with Amazon, this is the demo that we put together that shows this capability. And I have to admit, I chickened out. I was going to try to run this live, but I figured since I was talking, it's just better to kind of play a video. But here we are taking a look at the Landsat imagery. We started in Redlands, California. And now I'm just scrolling around, and you can see as I scroll around, it'll automatically fill in with the imagery I need. These are all different widgets that allow me to do different processing on the fly. So I just switched band combinations to highlight different features that could be found within the Landsat imagery. But now this is where it gets interesting. I click on the info button, and I just simply drop a point, and I do a spectral profile. It says, that's concrete. It's actually March Air Force Base and the runways. I select another area, a body of water. Click on it, it automatically determines that it is a body of water. I'm literally doing feature extraction on the fly, on the web, anywhere in the world on the Amazon Landsat data. That's the power of this capability. So I can go in and I can do these searches. And what's more is, as I said, I can go any place in the world. Let's go to Iran and take a look at Qom and see how that looks. And so this is just trying to show you that there's no way that we can build a tile cache that we can pre-process all this data ahead of time. So I can go anywhere in the world and I can run the same processes, do the same types of things, simply through the power of that platform capability that we've put together. So in this case, I just want to highlight the vegetation, and once again, can I do feature extraction over this part of the world? And I certainly can drop a point, and now I'm getting desert area. And then finally, just to do someplace a little bit closer to home, I got to find an urban area there with concrete. Concrete's pretty easy. Though it is kind of hard to distinguish concrete from desert in some areas. So, but let's go a little closer to home, and we'll go down to Williamsburg and just show the last kind of thing that this little tool can do. And this is an app you can all play around with. Just go to Landsat Services, Esri, and this app is readily available, and you can play with all these different tools. But now I've zoomed into Williamsburg, pulled up imagery, and now you can see I have the same type of tools available to me. In this case, I want to do an NDVI, and the healthy vegetation stands out against the forestry. I also know that I have a lot of water, healthy vegetation. There's my tassel cap, which highlights very vigorous vegetation, making things somewhat blue. But then my favorite is the bathymetric view, where I'm actually penetrating water depths and seeing the channels inside the rivers and the streams. And then one last thing before this demo runs out is I have access to the complete stack of the temporal imagery. So I can go back into time, I can run the same analysis, look at the same things based on the complete stack of imagery that's available to me. If I have the time to run it, I can actually do a spectral profile of all the imagery over a certain point and show you what the value is for that particular area. So it's a very comprehensive image processing capability. But let's move on and talk a little bit more about the analytics, because this is where it really gets good. I worked for ERDOS for 20 years after I got out of the Army. And ERDOS is probably one of the finest image processing packages that's available out there. Envy is catching up and maybe has even surpassed them. But when I came into Esri, I kind of had this, do these guys really know imagery? And they were working on a project called King Kong. And it was like, what's King Kong? And it turned out that we needed base maps to compete with other companies that have global base maps. And so the way we got there was that we bought the entire Iconos library of imagery. To get the best deal that we could, we bought the raw imagery. Unrectified, full cloud coverage in some scenes, the whole 9 yards. We just bought the whole archive. We sent it over. We did not have enough hard drive space in total at Esri to store it all. And so what did we do? We started pushing it into the Amazon cloud. And that's where we discovered these things, because King Kong actually became our complete ortho rectification production platform, all 100% based on Amazon and working in the Amazon cloud. And what was nice about King Kong is we figured out how to take maximum advantage of low-cost storage, S3, set up processing nodes against that, and then we could spin up as many AMIs as we needed to crunch that data. How many of you have done ortho rectification before? It's easy if you have sensor models in various complex things. So we tried to push that a little bit harder, and instead of doing just the Iconos imagery, we got in contact with one of our customers, APFO at USDA, and it turns out they have this historical archive photos, millions of photos taken since the 50s. And they came to us and they said, let's do a pilot. And so we put together this solution of scanned aerial photos that were taken before GPS even existed, before computers were really anything other than a mainframe. And we took those photos, we had them scanned, and we ran it through the King Kong process. And the end result is what I'm going to show you, is this particular data set of Davis County. This was our test area. About 1.5 terabytes of imagery just in the test area. And what's more, it was historical. So we had the bare minimum camera information. We had no 1965 elevation data. So from the stereo pairs, we actually had to extract the elevation data so we could do the ortho rectification. And this is the end result of the data set that we got. This is Hill Air Force Base. And as I zoom down into this area, you can see old planes up here, new planes over on this side as I swipe back and forth. You can see how much change has occurred. This imagery was actually taken in 1965. So 50 years difference. You'll notice here, the aircraft now on static display are actually newer than the aircraft that are actually being flown when the imagery was taken. Just to show you how much times have changed. New high school being built. Just comparison of how this part of Utah has changed somewhat significantly. Now, this is also right along the Wasatch Range, just north of Salt Lake City. So obviously, lots of changes are going on. This is Interstate 15. And when we showed this to our customer out in Salt Lake, where APFO is located, I happened to mention, notice that Interstate 15 is under construction. And they looked at me and they said, it's still under construction. So, but that just shows you how much change. You can see the loss of agricultural area around this particular region. And then the final one, let's see if it jumps to it here. I was going to try to do this live, but there isn't even a mouse, so I would have struggled horribly. So trying to do this with a touchpad. This, by the way, is one of our story maps that we use in ArcGIS Online. It allows you to quickly, it's a template that allows you to quickly put together information products for different users. And then this particular data set over here, I'd like to point out, is actually NAPE imagery. I don't know, are any of you familiar with NAPE imagery from USDA? It's 1 meter, and they collect a third of the nation every year. We have also put all the NAPE imagery online for our customers in the Amazon cloud. So you have access to it, and what's more is we took it in its native TIFF form as opposed to the Mr. Sid compressed, so you can actually do analytics against it, change detection, those types of things. This final area that I'd like to show you is this baseball field. And look at that pitcher's mound. And when I do the swiping, that'll give you the degree of accuracy that we were able to achieve with this particular data set. So the NAPE imagery was ortho-rectified to USDA specs, and we were able to match it with the 1965 imagery. Just think of how many Little League pitchers sat on that pitcher's mound for 50 years throwing baseballs out. So driving on, once again, you know, what good does it do you if you can't share the information with other people? And this is an area that we're working very hard on. I don't know if any of you have heard of it, but we have a new capability called the Web App Builder. And what this tool allows you to do is to go into a library of different widgets. And all those little imagery tools that you saw down the side of that particular app that I showed at the beginning, those are all widgets that you can find in this library. We also have a number in GitHub, so you can actually pull in others, and we continually update it, and our partners continue to update and add more and more widgets as time goes on. And these can be as simple or as complex as you like. But it is what drives Web App Builder that allows you to put together nifty apps that you in turn can then share with other people. And so my last app of the day is something we call Change Matters. And what I've done is I've actually set up this app, and this was actually put together with Cass Green, who was here in the audience earlier. But what Cass has put together, oops, I got to hit enter one more time. Oh, Cass would be very disappointed. Anyway. You're going to play? Oh, well, sorry about that. But anyway, this is probably an AVI and not an MP4, so curses. Anyway, this is a great app that was put together. It takes a look at different epochs of Landsat imagery and does automatic change detection between the image pair. And what I actually did, when you see this live, this is actually Cape Hatteras, and you can see this was taken in 2005. And this image was 2010. And you can just see the differences that have occurred along the coastal erosion side of this. So this is a very detailed app that has a lot of information in it that we're actually doing change detection on the fly using the Amazon Web Services to support imagery for the entire world at different times or at different epochs, different years. So in summary, this is the way it all looks. We have the cloud with the content coming in. We have the analytics that allows you to do the processing, which is so critical. You have to find those patterns. And we have the tools to build the apps. And you can build very complex ones to do the different types of things that you need it to do. And then finally sharing that out with the end users. That's my presentation. Any questions that people might have? If you're curious, the Web App Builder automatically now comes with your ArcGIS Online subscription or with Server. So that's something that's freely available as part of the solution. No questions? Oh, we got one back there.
The first web page that you showed, You're in Command, I guess that was the title, where you could do live analysis of Landsat imagery. Is there a way to access it online? I mean, what's the address?
I will provide all the websites to each of those sites so you can play around with it. Is that okay?
Yes, that's awesome. Thank you.
Yep. Yep. Any other questions? Well, thank you very much, and I'll be here the rest of the day.